Yes.
Good afternoon, everyone. Welcome to BIOMES. BIOMES stands for Bridging Issues and Optimizing Methods in Environmental Studies, and is YSE's flagship seminar series, providing a platform for cutting-edge research and impactful work through storytelling. Today, we are delighted to welcome Dr. Rohini Pande, the Henry J. Heinz II Professor of Economics and the Director of the Economic Growth Center at Yale University. Dr. Pande is also the Faculty Director of Inclusion Economics at Yale, an elected member of the American Academy of Arts and Sciences, a fellow of the Econometric Society, and a former co-editor of the American Economic Review Insights. Among her many accolades, she received the 2018 Carolyn Bell Shaw Award for promoting the success of women in the economic profession and the 2022 Infosys Prize in Social Sciences. Before joining Yale, Dr. Pande was a Rafiq Hariri Professor of International Political Economy at the Harvard Kennedy School. Dr. Pande's research focuses on how institutions shape power dynamics and economic, political, and environmental inequalities in low and middle-income countries. She is particularly interested in how public policies can empower disadvantaged populations and how ideas of economic justice and human rights can drive systemic change. Through the Inclusion Economics India Center, she collaborates with the Indian government on gender-inclusive rural development digital policies, while her work with Inclusion Economics Nepal evaluates strategies to improve the quality of policymaking by local governments. Today, Dr. Pande will present her recent work, Early Warnings for Floods Reduce Health and Economic Damage, Experimental Evidence from India. Conducted in collaboration with Maulik Jagnani, this study examines a multi-year randomized controlled trial in Bihar, India, covering 3.6 million people across 319 flood-prone communities. It highlights how an early warning system for floods can mitigate health and economic damage, particularly in vulnerable populations. With innovative interventions, her team demonstrates the profound economic and health benefits of timely flood alerts. Please join me in welcoming Dr. Rohini.
Thank you very much, and thank you for the invitation to be here. I have to confess, I thought this was going to be 10 students and me sitting around a table and talking, so I'm more than slightly intimidated, and I'm also like, maybe my slides will just finish in 15 minutes. But all that to say, I was hoping to use this also as a way of talking about how this research project started, kind of what our engagement was, and I'd be very happy to take questions through it. To start by saying that one of the graduate students at YSE, Mike, actually spent a bunch of time on the field on this project and has supported it in different ways. So it's great to see these connections grow. So there's been a lot of, and this is joint work with Maulik Jagnani. He was a postdoc at EGC in 2019 and started working with us since then. So let me start with some just broad motivation, and then you'll see what we do. So I think this idea that one of the ways that climate change is going to impact outcomes is going to be changing precipitation patterns. And as we know, it's sort of unclear whether it's actually going to be in aggregate decreases or whether just changes and how it happens. So if you think even about California, while Southern California has been incredibly dry, North California saw more rain than usual this year. And one thing we see across the world is a rising flood incidence. While this is overall flood incidence, there's not just been an increase in what you can think of as hurricanes and coastal flooding, but also changes in riverine flooding. India, in particular, received 70% of its annual rainfall in just 4 months, between June to September. And this is, as a result, a point in time when you can see quite severe riverine flooding in parts of India. We're going to be focusing on Bihar. Bihar is in North India, is an extremely poor state. In fact, if it was a country on its own, it would count as the world's most populous low-income state. It's actually a very fertile state as well when it comes to agricultural crop land. But 3/4 of its population in North Bihar, which is roughly 50 million, face floods on a regular basis. So we started piloting the work that I'm going to talk about today in the year 2019, 2020. At that year, in the surveys, what we saw is, the decrease in harvest or the impacts of floods on agricultural outcomes, I think, is quite well known, and we saw that in the reporting. But what I thought was interesting was there's also a lot of reporting of sickness to households. This is not, as I said, this is not cyclones. This is not something that's likely on its own going to lead to high levels of mortality. And the Indian government has now become very, very good when you have those kind of cyclones and actually doing large-scale evacuation orders. So this is, when you think of sickness, and I'll come back to this again, what you should think about is just rising stagnant water, unavailable clean water afterwards, rising incidence of things like cholera, respiratory infections, and so on. At the same time, we know across the world what's happened has been an incredibly great improvement in using kind of AI and machine learning techniques to improve flood forecasting. So what this shows you is the study I'm going to show you is based on a partnership with Google. And so when you look at this, the blue line tells you what just the actual observations are between across 2019 in terms of water levels. The green is Google's 48 hours alert, and the pink is the existing alerts that were used by the government, which were really based on just physical manual checks of river gauges. So what we've seen is a forecast such as Google's, and I'll talk about it in a lot more detail, have hugely improved in prediction. And I think one of the things I wanted to encourage the students to think about is that, just having broad conversations often is very useful. So I was actually in 2018, when I was still at Harvard, and I was talking to a colleague of mine who had moved part-time to working at Google. And, he had met the person who was running their flood forecasting unit, which had actually started because the head of Google his parents lived in Chennai in South India and had seen a lot of flooding, and he had been very upset by the quality of forecasting. So very unusually for Google, they put an entire product engineer team to actually improve forecasting. But at that point, there was not much of a social case and certainly not much of a financial case for investing in this area. But when I was talking to them, they were like talking a lot about how machine learning could improve the predictions. But then when you ask them about how exactly are you getting the message out there, the answer is very much, we just blast all the androids. And you're like, have you been to a village in Bihar? The average person there probably does not have an Android phone in 2019 in order to get at this. So that's really how the conversation started, was a set of people very proud correctly about the technology advances they'd made, but I think not much sense of what the last mile would take. So the first couple of years when we worked with them, we were also learning. But a lot of what we did at the very early stages was actually provide, through a set of qualitative surveys, information, for instance, on just even in the interface on either the website or when they blast out the message and you can click on a link, sort of how do you, for instance, explain height that is going to rise? If you just do it in terms of inches, people are not going to necessarily follow it. So when you talk to villagers, what they want to know is it going to come up to my knee? Is it going to come up to my waist? Or is it going to come up to my shoulder? And so helping them think about, if you want sort of human-centered design, was one way we helped them. It seems very far away from research, but it was, I think, both very useful in getting a product that seems to, as you'll see, work, but also, I think, getting a lot of buy-in from Google on working with us on this. Now, this is again, so 2019 was the first year Google launched the survey. Launched its service. And at this point, when it launched its service, it was just blasting it out to Android. So that's what we were studying in 2019. And what you can see is it was a year, 2019 was actually a year of quite high flooding. In our sample, 96% of the households faced a flood, but only half said that they received alerts. And so I think that was our motivation going in. This was the kind of data we showed Google up front to say that, we need to really try to do something a bit different. And it was clear that, these last mile delivery failures, some of it is, yes, not having a smartphone. Some of it is not understanding what's coming through to you. And some of it, even for those who got it, lack of acting on it may be, for instance, issues of trust. There's also a question that even if you get these early warning systems to work, they only have a lead time around 48 to 72 hours right now to be accurate. And so there's also a question of how much can you actually do? There's recently been a lot of a lot of discussion about anticipatory cash transfers. So for instance, if you believe that the big constraint households face is actually having the money to undertake actions to prevent, then just providing this information, even if we can get in the hands of who needs it, may not do very much. So this was sort of the context against which we got into the field to try to evaluate this early warning system. Just to be clear, our intervention or our what we do is not about improving forecasting. This is an improved forecasting model produced by Google. And it's actually a product that they continue to disseminate the same way throughout the state. What we're going to be doing is working with them in a random subsample to ensure that a higher fraction of households actually get the alert. So let's start with what the model is. So this is the Google model. So what they do is they develop this Google hydraulic model, and it's based largely on long-term satellite imagery, their predictions on it. But there is real-time data that goes into it, which is why there's this 48 to 72-hour lag, which is from the water gauges. So across Bihar, at least in the area we're working, the 36 water gauges, basically twice a day, once in the morning, once in the evening, someone goes to the river, measures the height, enters it in the central system. It gets transferred from the central system from this by CWC from the government to the Google hydraulic model, and then that gives out the prediction. And that's one of the reasons why it's only 48 to 72 hours, because it's really based on real-time river increase. I'll come to this at the end. Now what Google has done has realized that, especially in Africa, this kind of model was not going to work well because there are no water gauges. So now they have a model that is fully predictive based on satellite imagery and long-term patterns and doesn't have a real-time input. And they started in 2019. I think in 2022, they've launched a flood hub, and the flood hub now covers, I think, 22 river basins across the world. So this is something, if for students, again, thinking about research, you can go and look at this for several countries. And I think certainly for a number of African countries, this is probably the best source available. How does the notification work? So what exactly is Google doing? So you can see, so this was, you'll get an alert saying severe flood situation. You can either see it there, and this is what it's going to look like if you went to your web and saw it. And then if you tap on it, it will tell you where it is and when it's posted. And the source is the Central Water Commission. So this is completely based on engagement with the government. And so that's what you're going to see. Typically, you're going to get multiple alerts. So you get a warning alert as it rises. And so when the river level usually rises by 2 meters, you'll get a moderate alert and a severe when 3 meters. And now, and this is something that we worked with them on, the alert now includes forecasted timing of when it's going to reach your village and what water depth. So what would we do? So this is a map of Bihar, and I think you can see there are many rivers and parts of rivers across Bihar. We started by purposefully choosing a sample to be a set of districts that have seen historically high flooding. I think there's an interesting question, and we are actually planning an intervention for next year, of thinking about whether we want to expand also to areas that are not historically flooded, because now what we're seeing every year is actually flooding is happening more also in places that were not historically used to it. But our sample is more historically flooded areas. Within these 12 districts, we sampled village communities, which are known as panchayats. So these are clusters of villages, usually within a certain population size. And we have roughly them divided half and half into treatment and control. So just to be clear, this is not a study where the control gets nothing. The control continues to get what I showed you, the Android app with the data showing up on it. There was a little bit of a difference in the first year, the Google Flood. So we started, as I said, in 2019, we piloted. Then COVID happened. And so then we really went back to the field in 2022. At this point, we've just completed a survey for this year. So we have a 3-year panel of following the same households across years with the same intervention. Data is never processed as fast as you want. So we don't have the data for 2024 right now. So I'm going to show you results from the first 2 years, which is 2022 and 2023. In 2022, in some ways, our intervention, you could say, is slightly weaker because this information in the control, not in the treatment, I'll talk about what the treatment is in a second, in the control was just available on the website because Google wasn't functional. In 2023, it was on the website, plus it was a web-based Google form. And again, I think the other thing to remember with Androids is even if they're pushing it out to Androids, it can only work if your location feature is on. And typically, I think you should think of less than 50% having the location feature on. So that's the control. In the treatment, what we did is the Google system functioned as is, but we worked with a local NGO group, Yugantar, and we had paid community volunteers who were in charge for alert dissemination. So how did they disseminate the alerts? So the first thing was that in the center of the village, we had a system of putting up flags of different color, yellow for moderate and red for severe, which would go up when there was, based on the alerts, which the volunteers were trained to do. We also, in the first year, they sent out messages through WhatsApp. And the second year, we formed WhatsApp groups. So any of you who've worked in India, you should know that WhatsApp groups are like the way people function for getting messages out. So as I said, in 2022, it was both these methods. In 2023, we actually reduced the number of volunteers because we felt we didn't actually need 3. And we also started disseminating much more broadly through WhatsApp. So there was more emphasis in the second year on WhatsApp. We continued to have the flags, and we also had loudspeakers. I think the one thing we realized why WhatsApp, as long as enough people had it, was useful, is you can imagine when there's a lot of rain, it's very hard to ensure that actually volunteers are going around with loudspeakers and getting very wet giving it. So you can manage the flag hoisting, but it's harder to manage a lot of going around with loudspeakers. So let's see where the treatment and control look similar before I start getting into differences. So this is looking at 2022, and this is the percent of villages who had at least one flood event. And so this is at least one event that on the Google system shows up of at least 2 meters rise in the river level. So you can see there's no difference between treatment and control, which is what you should expect. Importantly, 2022 was a slightly higher year of flooding than 2023. 2023 was relatively low, even though 60% got flooded. 2024, which is the data we're analyzing right now, which is last season, was actually a very heavy year of flooding. So I think one of the things that's nice of being able to do this over multiple years is that we are going to be able to also look at differences across different levels of floods. And as I said, in 2022, if you look at the number of days you're flooded, not just whether you were ever flooded, you can see that intensity was much higher in 2022. So 2023 was definitely a lower year of flooding. Okay. So we have, at this point, after a lot of gives and takes, but now it's been, I guess, almost 6 years that we've been trying to get this working. Intervention takes a pretty standard form. So the intervention itself, we train the volunteers in May. And so we start paying them from June. But you should think about the main floods that happen in Bihar actually slightly later in August, September. But the intervention goes from June to October. We learned that it was important, and there's a slight difference first year, of doing a midline survey if you want to know about reach, because there's a lot of recall bias, as you can imagine. So if you only wait till after the entire intervention to kind of start understanding how much of a first stage you have or how much people are being reached by the intervention, you start getting a pretty noisy estimates. So we started a telephonic midline survey. In the first year, it was a smaller sample. Now we do it much larger, where we're actually just interested in knowing, what did they hear? Where did they get their flood alerts from, and the extent of protective actions undertaken? And we've constructed, in the first year, we constructed a panel of roughly 5,500 households. And these are end-line surveys we do. And we now, as I said, completed 3 years of it. And I think the attrition is quite reasonable, between 10 and 15% in both the second and the third year. And this is the data we're going to use to look at the impacts on physical health and economic well-being, and also to understand what forms of adaptation occur. Okay, so this shows you just the questions we asked them on how many alerts did you receive. And so you can see both in both years, we see a first stage in that you're likely to receive more alerts, or remember receiving more alerts. In terms of, as I said, access with some effort, the access certainly in 2022, you could argue was possibly different because you had to go to a website. In 2023, Google was fully active, but because we were using this WhatsApp, I think direct messaging, we had much higher reach in our groups, and people got roughly 4 times more alerts. It's also that the information they're getting seems to be better. So when you ask them typically, when you receive this alert across these months, in the treatment in both samples, they're more likely to get it before the water reaches the panchayat. And this was something that repeatedly we heard them talk about as being very important for them if they want to take under actions, is to get the alert before the water reaches the panchayat. Just to give you a sense of, a lot of these villages are by the river. So if they're not relying on our messages and they're not relying on getting the Google alerts, how are they learning about, I think I have that maybe, yeah, I'll have that in a minute, but the kind of ways that they're using to get information is either radio, television, if it comes on that, but and neighbors. And then another thing in a lot of these places is the boatman. So all of these villages will have some boatman who will shout out if they see the water rising. But this particular region, one of the other issues that kind of is orthogonal to our study, what happens every year, is the main river in this area, Kosi, comes from Nepal. And at some point when there's enough water, Nepal opens their barrages. And there is actually, for various geopolitical reasons, there is no cross communication at that point. So there is also often, and this happened this year, a point when you will have, I guess, an equivalent of a flash flood, which is not something that's going to get predicted well by Google, because that's just when the barrages are opened. But when you ask them about trust, trust you can see is relatively low in general. So that is an issue, but it is higher in the treatment group. So then I think what's important to ask is, how was the flood alert relate to you? So this comes to what I was talking about. If you look at the control means, as I said, in person and some amount of outreach is important, but the main change that we see is that we see a much larger increase in what is described as IT-based. So the IT-based is SMS, WhatsApp, phone calls, smartphone, and computer. We also see some rise in government, but that's small. But I think the main way you can think about this intervention having worked is, even though it was volunteer-based, I think we found that what really worked was these volunteers who have access to their phones and so on, that works. And outreach has some effect as well. But really the IT remains important, but it's just better than just pushing out on phones. So now let me turn to sort of what we find. But before that, let me just stop to see if there are any questions on just the design of the intervention overall. Go ahead.
Yeah, so I think share the people who responded on how they should got the flood alert. I was just surprised looking at the numbers for the government between the treatment and the control. Did the government deliberately focus so much more on the control?
So the numbers are quite small. So if you look at the control mean, I think what to me is striking, it's only 7 to 9% across the 2 years who say they're getting that information from the government. And that includes TV, radio, and newspaper. I can imagine newspaper being hard, but you would have hoped community radio is actually seen to be quite a large feature in these areas, but you don't actually see much effects of it. And so, as I said, I think you see some small increase, which could also be misperception, but the magnitude increase because of treatment is very, very small. In contrast, if you look at the magnitudes in IT, that's really 3 times the size of the control there. Okay, so, you know, one thing that was interesting going into this study was what do we ask about, right? I mean, there's a bunch of qualitative work very useful on thinking about adaptation, but it wasn't very clear where we would expect to see effects. So what that meant is the temptation which we totally gave into was to ask about a lot of different margins, but we also realized that we needed to tie our hands in some ways so that we don't show you 30 different outcomes and say, look, here are 3 that are significant. So we tied our hands by saying that we're going to focus on 3 or 4 categories of indices. And so I'll show you the overall effects of indices, which you should think of as a z-score. And of course, that's not very informative in actual behavior because it's some number of standard deviations change in index. But then I will go through the components of the index. So that's sort of how we're going to go through this. So, so in terms of just our estimation specification, it's a randomized control trial. So the specification is very straightforward. We just show, we're pooling across rounds. And we're going to show treatment effects. And as I said, the outcomes are our KLK index. What, however, was important, you can imagine that no matter how well we do the treatment, if an area has no flood, we should see no effect, right? Because on adaptation, because there was no flood. So we had an issue, and we're still refining this a little bit on exactly how do we identify the extent to which an area was affected by flooding. So what we want to do is we don't want to use kind of the alert data, because the alert data, you can imagine itself will have some type 1 and type 2 errors, right? Some of these alerts may actually not translate into real floods. So we want to use actual flood data. And so what we're going to do is, and I'll talk about in a second, we use a measure which is going to capture index of flood severity, which is based on actual floods that happen in that village within the day or 2. Right now, what we do is we wanted to also tie our hands. So since we had to come up with a measure in 2022, we said, okay, we'll divide it by terciles of flood intensity in 2022, which means, as you can imagine, in 2023, we have very few observations in the top tercile because it wasn't defined. But here's an area I'd be very happy, and I'd love to get feedback, because this is something we're still trying to figure out, what is the most hands-off way of doing it. We're getting some more data from Google to look at that. So right now, what do we do is, to be specific, is this. We use the objective data from the 26 water gauges in our sample. And we define a flood event as if you're in a village covered by that water gauge. So that's the closest water gauge for where the river is. And we define a flood event as starting when, according to the water gauge, the water went above the severe threshold. So that's 2 meters above your normal. And it ends on the day the water level went below the warning threshold. Again, looking for up to 6 consecutive days. We then define on a yearly basis the flood severity as the unweighted mean of the z-score of 3 different variables. How many floods did that village have, flood events did that village have in the season? How long was the average duration of floods and the average intensity of floods? We're also now trying to get the data so we can just use a measure, which is the number of days of flooding, which is perhaps, the simplest measure to use. But, as I said, all of these measures have some pluses and minuses. So I'd be happy to chat about what other measures we should possibly be presenting. And so I'm going to show you for today sort of these stacked estimates where we're going to stack our sample of 2022 and 23. And we're going to, as I said, kind of define it by, I'll show you effects for the villages that had no floods, and then by the 3 terciles on it. So let me just give you some intuition of what happens if I turn to the index. So the first measure that we're interested in is what we call ex-ante adaptation, is what do you do when you get a flood alert before you get the flood. So this is what we see in our data, what you do. You kind of, we asked them what are the different activities you did. So 33% of the respondents said that they would get supplies. This would be clean water, food, medicines. They would try to treat their land, kind of either around their house or the land, kind of clean up the drainage canals that they have. Not many, these are poor households. Not many of them have motors to drain water, but if they can, they will try to rent one. A very important thing for them is moving their livestock up. I think that's an extremely valuable asset. So they move their livestock up. They move their assets, and we're going to see, actually, this is an interesting dimension. So if you're a poor household, you really don't, now everyone talks about how you have a digital wallet for all your IDs, but you really don't want to lose or, have your ration card or your pension card get waterlogged. And then, I think what I want you to notice is that kind of what sometimes you might think of as a very common flood activity is just to move your household is actually very little. So less than 10% do that. And that's really a combination of both. These floods tend to not be that severe, like, you don't need to move necessarily. But also, I think their priority tends to be their livestock, which they want to move and be nearby. If there is movement that happens, interestingly, it's actually the men that leave with the livestock first. So the women and children stay behind. And then if you have a house that has a roof that's permanent, you'll go and sit on the roof. And if you don't have that, you'll typically go to the nearest highway, which is usually seen as going to be above it. And I'm giving this context because I think when you're going to look at some of the ex post results, especially on health, this is the context you should think about. People who are possibly going to continue to be in those same settings after the flood, but don't have access to clean water, or they moved, so maybe a highway nearby. Okay, so as I said, when we do this index, I'm just going to show you the index to start with. Here, what we see is, and this is going to be typically the pattern I show you throughout, is all our effects are going to be largely concentrated in the more severely affected floods. And the indicators which come from that make it up are these stocking supply, securing land, protecting. I've talked about all of these. I think you can look here at the components of the index. And as I said, and I think this is very consistent with what we saw, is really the livestock is something they care a lot about. And that there you can see even in the means, that's something that moves a lot. They care quite a lot about land, but we don't see much difference there because I think anyone who can do it does it. And then this moving of assets, which often is actually in documents. The second thing we looked at is ex post. So the first ex post measure we look at has to do with physical health. So we're taking the reverse of negative outcomes. So there were questions, and I'll show you. Maybe I can try to see if I can get to this. Then always getting back is a bit stressful, but we'll try here. So these are the illnesses. I'd say one thing, and one of the things that we are now hoping to do next year is actually try to figure a way of collecting some biomarkers. So I think you should take the measure on types of illness with a pinch of salt, because as you can see, the most common in the control group was to say you had fever, right? I mean, so people are not often getting a lot of medication improvements. What they say, there are kind of reductions in where we see the most is on respiratory illness. We also see some here on the no floods, which is a bit puzzling. But I think the main thing I take away on trying to get these very specific measures of sickness is that, this is not a place where surveys are going to give us a great result. These are poor populations. They don't go to the doctor. And so I think we're trying to think about how to do biomarkers on it. But when we have these three categories of sickness, injury, and death, you see some small effects. So these are all reversed. So you should think of them as not dying, not being sick, not being injured. What you see is, as I said, death is not a large common effect of these riverine floods. And we see very noisy, small effects there. But we see large effects on sickness and injury. And this is going to be relevant because this actually tells us that these are outcomes that may have economic consequences in terms of things like medical and health expenses, which is what we're going to turn to next. So when we look here, what we see is, again, a reduction in the number of members who are sick or the days they're sick, number of illness symptoms. But the effect that actually is quite large, this is in thousands of rupees, is the reduction in medical expenses. So one of the ways in which we think that actually an improved early warning system works is it's reducing in a season, it's reducing your health spending by 6,000 rupees, which for these households is roughly something like a quarter of their monthly total income. So, this is a reasonably large expense that they end up facing. And consequently, as a result of this, when we look at economic well-being outcomes, we see an improvement in economic well-being outcomes. And as we'll see, a lot of these improvements in economic well-being outcomes are going to come from less indebtedness. So I'll go into a bit more detail here. So it's these coping measures where we see there's a big change. So let's see what these coping measures are. Is that you're less likely to take out money from savings to mortgage assets and reduce consumption of essential items. And the loan amount you take goes down by, in fact, a much larger, about by 17,000 rupees. So our interpretation is that really one of the ways in which these early warning systems have health effects that persist is not through a death, but is by reduced sickness, which reduces both directly in terms of things like days work, but importantly reduces the kind of health expenditures, which for poor households can be quite a large component of what they end up spending on. And this, I think, one of the things that we're interested in. So right now we have funding to the panel one more year, so we have at least a 4-year panel. And we're hoping that that's maybe a horizon over which we can start seeing what the cumulative effects of having had spent less on these sicknesses shows up. So that brings me in some ways to the last thing, which is really doing just a basic, this is a partial cost effectiveness analysis, because it's only looking off a single item, which is averted medical costs. But if you think about, as we vary the percent of households alerted, so we're taking quite a moderate effect, and we're asking for every dollar spent that is needed to kind of have the volunteer system going that will lead to them getting alerted. You have to make two sets of assumptions, obviously. How many areas are flooded, right? Because we saw these effects only show up for severely flooded areas. And then you have to ask how much was spent on it. And what you can see is that across the board, the averted medical costs are much larger than the amount spent. So even if you take a which I'd say maybe the average year, let's say you have 25% of the villages in Bihar are affected by floods, which is, I think, a very reasonable thing. And let's say you manage to alert just half the households in the village, you're still going to end up with something like averting $40 of medical expenses for every dollar you spent on the scheme. And so in that sense, it seems like, and again, this would be even higher if you start now trying to put into account kind of the interest rate and the loans that you might have to take in order to meet these expenses. So overall, our sense is that there's been a lot of push at the level of the UN and others right now saying, we need all the world covered by early warning systems. But much of the attention of the spending right now is really just going on the infrastructure to set up these kind of technological models to have the flood alerts. There's very little attention on the last mile. And certainly it's going to vary. So I'm sure if you're in not a very densely populated part of Africa, unlike Bihar, it's going to be more expensive. But this starts to give you some sense that it is, in a lot of settings, it's going to be very cost effective to undertake this. So let me just kind of conclude by saying that I think in 2022, the UN Secretary General launched an early warning for all and asked for investments over $3.1 billion over the next 5 years. They're halfway through it. And this is very much kind of an AI-driven promise, this idea that there's been incredible improvements, which is true. We see, I didn't show you the results on that, but what we see is that overall, if we compare, which we can do ex post, the number of times flood alerts were put in places that didn't get flooded versus not getting a flood alert and it flooded, you actually find that on average, you're definitely forecasting accuracy is higher in treatment areas than control. What we did was kind of focus on this last mile dissemination, and certainly in the parts of India where we work on, we think this is essential, even though by now there's a whole battery of SMSs arriving in the household on a very regular basis. The area we worked, I think, is home to some of the world's poorest populations. There are 600 million residents in this zone, and over 200 are poor. And I think the final thing I'll end with is, there is a lot of interest right now in anticipatory cash transfers. So I think there was important work done on this, I think, in Bangladesh, but, Give Directly in a lot of Africa is pushing for this idea that we should use these forecasts as a, kind of an adaptation tool, is use the forecast and make anticipatory cash transfers. Maybe, I know Esther Duflo is pushing the view that the billionaire tax should be used for this, but right now the billionaire tax seems very far away. And so I think one of the questions that we are going to look at also is, how many households are actually constrained by not having enough money? But you can certainly go quite far with this information. And if we think that some of the main benefits are really averted medical expenses, then you could possibly focus on this in the absence of a billionaire tax and go a long way. So let me stop here and open up for questions. So thank you very much. Yeah, please.
Yeah, thanks so much for your talk. I study rivers too, and there's sort of like a Murphy's Law of river science that if you get 3 years of funding to study river floods, your region goes into a drought. And my question kind of stems from that is, I found the flow intensity really interesting, or the flood intensity metric. And so was that metric just over the 3 years of your study? And if so, like, how did these floods fit into like a historic context? Like we often talk about like 10-year floods, 20-year floods. This is why a 3-year study makes it difficult. So like how'd you do? What sort of floods did you
Yeah, no,
catch?
thanks. That's a great question. One actually we are in the middle of thinking about, so I'd love to talk to you more about it afterwards. So I think there are two different questions. What we're looking at is the impact to a flood that arrives today, right? So in to that extent, we care about the flooding today, but you're right to place it in the context of how severe was this flood. Ideally, we would have like 20 or 30 years of flooding to say how severe it is. And then there's also a question of how much do you benchmark it, something that may be not very severe on average, maybe very severe for this village because it never had a flood before. So, so the things that we're trying to do right now is exactly try to figure out how to go between the two. So right now, all we're doing is we are basically using the data in 2022 to get to it. There was a Nature paper that for all of the world, and therefore for our areas as well, now gives these flood estimates starting from 2019. So we can use that to benchmark how much earlier they are. But I agree with you. I think it's the two issues to it. One obviously is what was this the true flood intensity? The second is what matters for a village, right? A village that never had a flood before, should we think of a different flood intensity measure for them? So do we take in some sense terciles of the average what we're doing, or should we have things that are very village or block specific? So I'd love to talk more to you about it. Yeah.
Thanks, Rohini. Super interesting. So you're studying the responses of people and we're making statements about villages. So I'm kind of curious, how much turnover of people is there in these villages? And if there is turnover, is that systematically different in your treatment from your control? Not because it's contamination, but
As a response.
does this actually say, is this like a signal that these villages have better public services or something and are more desirable to stay in or more desirable to move to? Or I don't know.
These are areas with a lot of migration in general. So you're absolutely right about that. We haven't yet seen, and we've been collecting it every year, of migration responses that are very strong to it. But I think the broader question, which is also for our cost effectiveness estimates, if if villages are different sizes, also, how do we account of that in thinking about what a 25% means? Because presumably the cost is per person, not by share of villages. So I think that's something we need to do more on also. But we haven't seen right now this sort of endogenous response, people think of these as better villages. But yeah, what we've been trying to focus more is on looking at trust in these villages, whether that goes up. Yeah, please.
So my question had actually saw these health effects. And I think some of the other work that I've seen on like migration is like health is tied in with that migration problem.
Yeah.
So it's sort of surprising that you're not seeing
Migration effects. So you think
a migration effect.
But I think this migration is quite high and very seasonal. So in this area, basically what happens is this, Biharis are well known for actually migrating to do seasonal labor in other states. And I think if anything, probably the effect that I think we should look to see is what it does to labor costs. Because I can imagine if I have better flood warnings, I decide to say harvest a day earlier because I know that there's a flood tomorrow. And in a tight labor market, because there's been a lot of seasonal migration, or it might affect things there. So that I think would be interesting to see, and we haven't done that yet.
I really appreciate you talking at the beginning about the collaboration with Google, and I had a question about that.
Yeah.
Were you dependent on the Google engineers using their day off to work on this, or was it an official project? And did you approach them, or did they approach you?
So no, that's what I was saying, that I think it was kind of striking to us that it was an official project, and it was an official project because I think Sundar Pichai felt that he had personally invested in his parents having better forecasting. So it was very unusual for when they started to do this, have a product team. So they actually have a product team in Israel that's doing it. Since then, however, I think both because there's been just this huge interest in early warning systems and maybe AI feels the need for, they have a AI for social good unit, that this is quite a central part of. So it is actually, Google has put a lot of resources into it. And I think if you go on the web and you just look for Google Flood Hub, it's a whole machinery out there that they have for this.
You briefly mentioned looking for biologic markers of illness. I was just wondering if you could speak a little bit more on that, because dysentery is probably a stool sample that's going to be kind of tough to do. And how do we feel as economists about
No,
using
exactly.
that
So I think partly because we're not going to be in the field at the time when they have it, I think the kind of biomarkers we're thinking of really are height for weight and circumference measurements. So very non-invasive and ones where we may not find effects, but after 2 or 3 years, we do think, potentially stunting may be a place where you pick it up. So we're thinking of young kids, and we're thinking about these sort of non-invasive measures. The problem is we're just not going to be in a field close enough to the flood itself to pick up actual disease when it's occurring, like dysentery, something like that. It would probably have been cured by the time we get to the field. So we're looking at the longer term impact. We're also going to try to look for educational effects and schooling, because there is not clear what we'll see, because if a school just shuts down, that might be the first order effect, and the fact that households have a little bit more income, a little bit less illness may not be that much. But I think those are educational reports we're hoping we can get from schools.
Thanks, Rohini. This is just a clarification question. I think you said it, but could you clarify how you defined those terciles? I was looking at that and I just saw that the N was much smaller in the third tercile than it was in the first and second.
Yeah, because we defined it not annually. So we define, and I think this comes back a bit to the earlier question, which we're still struggling a bit with this. So we defined it on the basis of the 2022 data. So in 2023, because there was much less flooding, much more of our data is going to show up in the first and second tercile, or in the no floods. But I certainly don't think we've done necessarily the right thing right now. So that's the work in progress part that we'd love to get feedback on. Yeah.
Hi, thanks for your presentation. It was interesting. So it seems like you've pivoted away from the high cost intervention, which is the individuals in the villages. So are you considering scaling up, or how do you balance between?
So that's a great question. So we are actually considering scaling up. I think the extent of it may be affected a little bit by the government decisions right now on grants. But our current plan, which we have buy-in from the Indian government on, is to try 2 different models. So one is every village has what they call, so one thing that's clear, that any scale up effort cannot have people coming from outside the village, because during the flood season you can't travel, and you're probably not going to travel to a very flooded area. So we need to identify individuals in the village who are going to be willing to do this on an ongoing basis. And so the 2 models that we are thinking about is, one is now a lot of these governments are setting up kind of water management groups, just because another month there's droughts and the water management. So trying to see if we can train the water management people. And the other is to use these women's self-help groups. These were groups that were actually very active even during COVID and the pandemic, and so have some access to moving. So those are the 2 groups that we are hoping to work with this time. One thing that was interesting in it, we started by thinking we should just go to who deals with floods, which is like the disaster management. But the disaster management is very focused on kind of very large scale kind of cyclones and things like that. So they basically come from the military, and the solution to everything is we should have a siren. So we decided to move away from that after first thinking that would be the natural place to go to.
We have time for one more question.
Thank you so much, first of all, for the presentation. I just wanted to check what is the timeline of the study you're looking at? Because if the preliminary results are showing that your last mile connectivity is helping people and helping them adapt to floods, what is the timeline, and till when will the control groups also start getting the same level of support?
That's a great question. I think one thing that we hope is better that we're not, we know that whatever the government system is there for everyone. So I think this comes to the scale up question. We need to figure out what the scale up model is. So this season, we were hoping to try these 2 different scale up models, the water management and the self-help groups, and then just kind of work with the government on that. We'll see how far we can do. We may be more constrained on budget than we thought we would, but we felt it was important to have 1 year of evaluating the types of scale ups before we actually tell the government this is how to do it.
Great. Thank you so much for being here, Dr. Pande.